Hello students, I am Dharmendra Pathak. In my previous video, I will describe about general basic concept of chemistry. In that video, we discussed that what is element, compound, mixture, from which compounds are formed, like atom, symbol, radicals, molecular formula, and molecules. Today in this video we discuss about how to write a molecular formula. What is atomic mass? Relative atomic mass, formula weight, and percentage composition of element in the molecule of compounds, and also about types of chemical reaction. At first we discuss about how to write a molecular formula. According to our previous video, here we write molecular formula by applying simple crisscross method, and to write molecular formula it is necessary to learn symbol and valency of radicals. And here we write how to write molecular formula of the compound. Here. To write molecular formula of the compound, what is needed? Compound needed. And here we should write at first we write name of compound and identify radical present in it. Because all compounds are made up of two radicals, electropositive and electronegative. In second step, here we arrange radicals with valency, and in third step we apply crisscross method to write molecular formula of the compound. Suppose here we consider that name of compound is here sodium chloride. Then how we write a molecular formula? At first we find out which radicals are present in it. So here sodium chloride are present there. Symbol of sodium is Na, chloride is Cl. Valency of sodium is 1, chloride is 1. In that condition, we exchange valency of radicals, that is valency of chloride becomes number of sodium goes with sodium, valency of sodium goes with chlorine, that is called crisscross method. And here we got Na no need to write 1 chloride Cl. In this way, by applying crisscross method, we can simply write molecular formula of the given compound. Second compound, we consider that potassium chlorate. That potassium chlorate compound is made up of potassium radical. Another next radical electronegative is chlorate. And potassium is denoted by K. Chlorate symbol is ClO3. Both having valency 1 and 1. And when we crisscross it, then we got potassium chlorate is the simple molecular formula. After that, we discuss few molecular formula of few compounds, and you all should practice much more to become efficient to write molecular formula of the compound. And several name of compound I will provide you in the link, and also solve from your book. Suppose we consider third is here ammonium sulfate. Ammonium sulfate compound is also made up of two radicals. These are ammonium and sulfate. Listen here, two radicals are there. Ammonium sulfate, symbol of ammonium is NH4, sulfate is SO4. Valency of ammonium is 1, sulfate is 2. And when we apply crisscross method, if compound radical comes, then we should write here NH4. If we direct write 2, then it becomes only for hydrogen and value get changed. Therefore, by adding number in compound radical, we apply bracket NH4 whole 2. And 1 goes with SO4. Then no need to write that here 1. And here it is called molecular formula of ammonium sulfate. Now again we write more formula. Suppose ferric oxide. That ferric oxide contains iron and oxygen. And here we write ferric oxide. Ferric symbol is Fe. Its valency is 3. Oxide symbol O. Valency is 2. And then we apply crisscross to exchange valency, and we got Fe2 and O3. It is called ferric oxide. We can write more formula like suppose sodium silicate. That sodium represented by Na, silicate represented by SiO3. Sodium valency is 1, silicate by 2. By direct applying crisscross, we got Na2 SiO3. It is the molecular formula or methods of writing molecular formula of the compound when we know its radical and valency. Therefore, at first learn radicals and then apply crisscross method to understand molecular formula of the compound. And here we write molecular formula. What is molecular formula? And before that we should write here what is molecules. A smallest particle of the compound which has free existence and having all the properties of given compound is called molecular formula. Listen. As for example here, water denoted by H2O. It means what? Molecular formula of water molecule is denoted by H2O. Similarly, suppose quicklime is denoted by calcium oxide. It means molecular formula of quicklime is calcium oxide. Carbon dioxide is denoted by CO2. It means what? It is one molecule or molecular formula of carbon dioxide. And these molecules are represented by molecular formula. And we can write symbolic representation of molecules of the compound is called molecular formula. Of the compound is called molecular formula. Listen. Molecular formula of water is H2O, quicklime, carbon dioxide, limestone, denoted by calcium carbonate. In molecular formula, the ratio of element or atoms remains fixed. And here we write one more. We consider that glucose is represented by C6H12O6. It means it is molecular formula of glucose. And here we write significance of molecular formula. What is significance of molecular? What are the importance of molecular formula? So from any molecular formula, we know that which atoms are present in it. At first, it helps to know elements are present in the molecule. By observing molecular formula, we know that which element, suppose water, molecular formula is H2O. It means hydrogen and oxygen are present in it. Second significance from molecular formula, we know that ratio of the atoms present in it, and these two are related to which quality of elements are present, and therefore it is also known as qualitative significance of molecular formula. It is known as qualitative significance. If question writes qualitative significance of molecular formula, then we write molecular formula gives which elements are present in it. Other, we can know that here a ratio of elements present in it. Quantitative significance indicate that here it helps to calculate molecular mass. We can calculate molecular mass of the compound with help of molecular formula. Fourth importance we can write here, it helps to know about number of molecules present in 1 mole of substance. Listen. Or molecular or molar mass of the compound can be identified with help of their molecular formula. So these are called importance of or significance of molecular formula. And then we discuss about AMU, atomic mass unit. Listen. A smaller mass like mass of atom, mass of molecules of the compound, these are too small, impossible or difficult to measure and express in kilogram. On that condition, we apply AMU or atomic mass unit to express such type of subatomic particles and molecular particles. And here we write 12th part of mass of C12 isotopes of carbon is called AMU or atomic mass unit, or one standard atomic mass unit. And every atom has its mass, that is, suppose here we call it atomic mass. Atomic mass is considered as the mass of atom. Atoms are made up of electrons, protons and neutrons. Electrons having too small mass or negligible mass, therefore it is expressed in here AMU. Atoms are made up of subatomic particles like electrons, protons and neutrons. These three particles are too smaller, and among these three, mass of electrons are negligible, that we consider 0. And due to that reason, total mass of atom remains located at center, which is called nucleus. Nucleus contains protons and neutrons, and therefore we define atomic mass as the sum of protons and neutrons present in nucleus of an atom is called atomic mass. As for example, atomic mass of hydrogen atom is 1 AMU because it has only one proton in its nucleus, having no neutron. Atomic mass of oxygen equal to 16 AMU, or unit also we can write. It means atomic number is 8. That is 8 electrons and protons are present. Number of electron and proton remains same, and its nucleus contains 8 neutron. Therefore, sum of proton and neutron becomes 16. 8 proton and 8 neutron. Then 16 is its atomic mass. And here we consider about new one type of mass, that is called relative mass of atom. Relative mass of atom means what? We know that here relative mass of atoms. Naturally occurring elements contains various isotopes, or these isotopes are different in number of neutrons. That is, electron, proton remains same. Isotopes we can define that here atom having or elements having same atomic number but different atomic mass. That is, number of neutron becomes different, and here we write naturally found elements contains various isotopes. And average mass of these isotopes is called relative atomic mass. Listen, relative atomic mass found is always fractional, not in whole number. That is caused by, or it is fractional, because various isotopes exist in nature, and average value of mass of these isotopes becomes fractional, or average mass of these isotopes becomes fractional. Listen, as for example here, naturally found chlorine contains two type of isotopes, that is 17Cl35 and 17 chlorine 37 in the ratio 3:1. Then how we calculate that here? Then relative atomic mass becomes average of these two atomic masses, that is equal to first type of element is 35 and its ratio is there 3 plus another type of mass is here 37 and its ratio is 1 and total ratio is 3:1, that is 3:4, and we found that 105 plus 37 divided by 4, or when we add, then we got 7 5 12 2 3 2 5 1 3 1 4 by 4, and when we divide that, then 4 3 are 12, 2 4 7 are 28, 2 4 5 are 20, that is 4 7 4 3 are 12, 2 4 5 are 20, 2 4 35.5 is the, or AMU is the actual relative mass of atom, of one atom, relative atomic mass of chlorine. Therefore, relative atomic mass equal to 35.5 AMU. Listen, and that generally relative atomic mass can be calculated by which percentage of these elements are present naturally and what are its atomic mass. Then we can easily calculate its relative atomic mass by average method, and then we discuss about, here also we can take, now we calculate relative atomic mass of hydrogen. Like another example, a natural hydrogen contains 1H1 having atomic mass 1.007825 AMU, and 1H2, that is deuterium, having atomic mass that is equal to 2.014730 AMU. And here 1H3 masses that we consider neglected, that is caused by two less traces are found that include titanium. Then here we find out a relative atomic mass of in the ratio here given, in the ratio 6400 is to 1. Yeah. The relative atomic mass of hydrogen becomes first, the first ratio is 6400 part of 1.007, or here we write here 6400 part protium is found. The mass of protium 1.00785 plus 1 part another isotopes 2.014730 is found, and sum of average ratio is 6400 plus 1. On that condition, by adding and dividing, we got 1.008 AMU is the relative atomic mass of hydrogen. And then we find out a relative, or firstly molecular mass. Molecular mass, and we know that molecules are made up of elements, and here we write the sum of atomic mass or masses present in an atom is called molecular mass. As for example, limestone represented by calcium carbonate. Its molecular mass becomes 1 into calcium plus 1 into carbon plus 3 into oxygen. 1 into calcium atomic mass is 40. Carbon, atomic mass of carbon is 12. 3, atomic mass of oxygen is 60. And when we solve, then we got 40 plus 12 plus 48 equal to 100 AMU is the molecular mass of limestone. And in this way, the sum of atomic mass present in an atom or molecule of the compound is called molecular mass. Another example, sulfuric acid, like a denoted by S2SO4, that contains 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen, and 2 atoms of hydrogen. Atomic mass of hydrogen is 1, atomic mass of sulfur is 32, atomic mass of oxygen is 16. And here 2 plus 32 plus 64, that is equal to 98 AMU. It is called molecular mass of the compound. In this way, when we know atomic mass, then we can easily calculate molecular mass of the compound. And now relative molecular mass. Listen. Relative molecular mass is the mass of, or how much time it is the 12 part of here given that here mass of carbon isotopes is called relative molecular mass. And here we write relative molecular mass of the compound is how much it is heavier than 12th part of mass of C12 isotopes. Yeah. As for example, here we found that here a relative mass of sodium chloride. Sodium chloride. That sodium contains one sodium, one chlorine. And here we put relative atomic mass of sodium is 23. Relative atomic mass of chlorine is here 35.5. Then we found that (23 plus 35.5) equal to 58.5 AMU is the relative molecular mass of the compound. If we add the sum of atomic masses, then it becomes molecular mass. Sum of relative atomic mass, then it is called relative molecular mass of the compound. In the next video, we discuss about percentage composition, empirical formula, and then about types of chemical reaction.